Hello, everybody. I'm Corey Summers, Chief Marketing Officer at ArangoDB, and we are so pleased to have you hopefully participate in our hackathon that we are sponsoring. It's called Building the Next Gen Agentic App with GraphRAG and NVIDIA cuGraph. And so we are sponsoring this alongside our partner, NVIDIA, and naturally working closely with the Network X community. If you are watching this video and would like to get more information about the hackathon itself, you can go to arangodbhackathon.devpost.com. All right, let's dive into it. Certainly, we have all the detailed rules and guidelines and resources on the DevPost site itself. So in this video, we're just going to be giving you a high-level overview of the hackathon. And then in the second half of the video, should you be interested in participating, and we hope you will be, Anthony Mahana here, senior engineer, is going to take you through the Jupyter notebook that will accompany this hackathon and give you step-by-step guidance all along the way, complete template so that you're not poking around in the dark for what to do next. All right, so why should you participate in this hackathon? Anthony, I think it's pretty clear. You always love to get that cutting edge experience, right?
Yeah, exactly. So we're actually quite fortunate to have partners with NVIDIA, NetworkX, and some of the folks on the Rapids team to develop some new technologies that we want to offer as a open source package available in Python. And some of this stuff has to do with a lot of the recent trend around Gen AI, which is RAG and especially GraphRAG. So we're excited to be giving you guys the opportunity to use those tools on some cool data sets that we think make sense for you.
And I think, Anthony, the applicability to real world use cases, certainly pushing the limits, showcasing the innovation. I know people, part of this will be a YouTube video, part of the submission, and that can be used in many different ways. LinkedIn profile, websites. We're going to be promoting all those videos on social media. And certainly prizes, right, are not the least bit of it. So we're going to have $30,000 in prizes, $15,000 for first prize. We have second and third and honorable mentions. Each prize has a social media promotion. Each prize also gets a blog post on our site. Who knows, maybe on the NVIDIA site as well. And Anthony, what about the career acceleration? I think since this is a hot area, GraphRag, it's going to be helpful there, right?
Yeah, absolutely. It's really nice to catch the wave at its early stages. And with GraphRag, things are just beginning to get quite established in the industry. So being able to jump on this quickly and showcase your skills around GraphRag can definitely give you an edge in the future.
Speaking of which, GraphRag becoming the hot thing now. Microsoft jumped on that bandwagon even about a year ago, right?
Yeah, exactly. And we've seen actually a lot of companies start to advocate for not only RAG, but making sure that you have a knowledge graph built around your system so that you can augment your retrieval engine with the traversal capabilities that traditional tabular data would not be able to take advantage of.
So let's quickly go through the 5 steps of the hackathon, then you can get to the notebook. So certainly choosing a data set is going to be critical. Now, the nice thing about this hackathon is you can bring your own data. So you can choose your own data set that's relevant to your organization, relevant to you personally. And there's the step of then converting that to a graph format, which I'll talk about. Or there are several data sets that we are providing around GoDB that you can use. They are already in a graph format, which means you'll be able to skip a couple of the steps if you want. Of course, the nice thing about bringing your own data set is you get to go through the whole process, but you are not penalized in any way if you pick one of our data sets. Now, if you do bring your own data set, you will then load that into NetworkX, and that integration between ArangoDB and NetworkX and cuGraph, that's really the novel thing here, right, Anthony?
Yeah, exactly. So we're taking advantage of a recent product inside of NetworkX called backends, NetworkX backends. This is a plug and play architecture that's been integrated into NetworkX, allowing third-party software to plug into NetworkX. So traditional functions that would normally be implemented by a NetworkX developer could actually be dispatched to a third-party developer. ArongoDB is essentially the first persistence layer to Network X in the sense that you can now store and maintain your Network X graphs in ArongoDB seamlessly with almost no code change. And this is something we believe the Network X community has been lacking for a long time, a dedicated and integrated database. And we're happy to be the first one.
And so you bring your own data, you then load it into Network X, persist it to ArongoDB through the integration pack is essentially that Anthony will show you in the notebook. And that is a quick step. And then the big piece of this is going to be you building the Agentic app. This is the creative piece, the functionality, the richness. This is where it's a natural language input by a user that will then access the data. Now, the beauty of this is that, again, if you're choosing one of our data sets, you can go basically right to step 3, make sure the data is in the graph and visualize, and then you can build the Agentic app. Now, since we are leveraging cuGraph acceleration using GPUs, that's going to be a big piece of this as well. And then, of course, step 5, you will be recording a YouTube video, public video that will go far and wide with your submission. Now, I want to talk just quickly about the architecture, which will lay a good framework for the 4 areas: data, tools, agent, and questions. Let's start with the Agentic app itself. You're going to have a user providing a natural language input. What we want to see here is a range of different questions in terms of complexity, and the agent being able to handle seamlessly all those different questions that come in. Anthony, why don't you talk about the different modalities of the tools here in terms of how the data is then accessed?
Yeah, absolutely. So with the data stored in ArongoDB, you can actually start to leverage our query language called the Arongo query language. Now, of course, because of our recent NetworkX ArongoDB integration, you can, by extension, leverage the graph algorithms available through NetworkX. So we're trying to propose an agent that is able to accept a natural language query and dispatch to the intentional tool. So for example, given a social network graph, a question like, who is the most influential person in the graph, would be dispatched to the graph algorithm tool responsible for executing a NetworkX algorithm, which could, in theory, be leveraged, a GPU implementation of that algorithm via cuGraph. Now, if I were to ask instead, who is connected to node 1 or who is connected to John Smith, then that's a simple graph traversal that can be operated via the database on server side. Or for example, update John Smith with attributes foo bar. That's another simple AQL traversal or simple AQL query that can be accomplished via the database tool. So we're trying to provide a template for you to either create workflows from natural language to the database directly or natural language to NetworkX by way of ArongoDB.
Now, let's be clear, the hybrid scenario where you're using both, or the application or the agent knows which to use.
Yes, absolutely. So if I were to instead reformulate my query to look like, who are the most influential people connected to John Smith? This would be a combination of both generating an AQL traversal to look at the neighborhood of John Smith and then applying an algorithm like betweenness centrality or PageRank on that neighborhood in an isolated manner in order to answer the question. So combining both the graph algorithm and the dynamic AQL tool is going to be something that we'll see as a creative aspect in the hackathon.
All right, so that's the architecture. And then there's some kind of extra credit things. Not that you have to do these to win, but what are we talking about here?
Yeah, so because ArongoDB is multi-model, we're able to offer a bit more than just graph. So we are a document database. We are a key value database that's JSON native. And by extension, we do offer some vector similarity functionalities. So you can store your embeddings on nodes or edges of ArongoDB data, and you have at your disposal similarity functions such as cosine or Euclidean distance to measure the query embedding against the embeddings that you store in ArongoDB. In addition to the vector similarity, we are also a full text search engine embedded into ArongoDB. This is called Arongo Search. So we're trying to encourage participants to explore the different multi-model capabilities of OrangoDB and come up with creative ways to convert those functionalities into agent tools. Okay, so I've got a Jupyter notebook here set up that is going to cover some overview and the context around this hackathon, as well as the main component, which is the template that contains code blocks that could be used as inspiration or as a placeholder or even as a skeleton to your notebook that you will submit. The overview section is just a quick recap of the hackathon, so we can skip that. I would recommend you check out the context section because this covers two key points to establish some background to this hackathon. Number one is the relationship between OrangoDB and NVIDIA. We've had a strong relationship for the past couple of years now, and it's only getting better with the work that we have through Rapids. The second is the relationship between NetworkX and QGraph. So they actually form quite a symbiotic relationship, and especially in recent events with the NetworkX backend concept, you can start to see how QGraph can be used directly inside of NetworkX with almost zero code change. Right, so let's move on to the template section where we can see most of the code blocks that can be used for your hackathon submission. What I've done is I've gone through and implemented a very basic version of a hackathon submission, or what could look like a hackathon submission, using the social circle network dataset from Snap. This is a very basic dataset collected from Facebook users that know each other. It's about 4,000 nodes and 88,000 edges. And in this case, because it's a dataset found on Snap, I can just download it and load it into a data frame, which we will see in a moment. Now, it's important to note that this dataset cannot be used for hackathon submissions. It's merely used as a sample to show you what the hackathon submission could look like. The first step is to install the required packages, and we start first by installing the OrangoDB NetworkX integration library, which is available as a Python package. I've left a link to its GitHub repository should you be interested to learn more about the codebase. Following that, if your notebook does have GPU enabled, you should be able to run these two commands, which checks what hardware you have in terms of GPU and confirms if you have the CUDA compiler version ready on your machine.
And what if you don't have GPU?
Right. So if you don't have GPU, then you would be limited to CPU only for NetworkX algorithms. However, based on your dataset size, this may or may not be negligible in terms of performance. But really, the important thing is to, speak of the GPU capabilities that the QGraph package offers and how it seamlessly integrates in NetworkX. You don't have to use a different package. It's all accomplished through the QGraph backend to NetworkX. Right. So in this case, we've confirmed that we can use a GPU, which is why I can install this additional package, which is exactly the backend that I just spoke about. There are some links provided in the hackathon description to show more about this.
So, Anthony, if people need access to GPU as part of this, what are their options?
Right, so we recommend using Google Colab or Kaggle notebooks to build out your notebook, especially if you don't have a GPU on your machine. Both of those services offer a free tier GPU, which probably gives you a couple hours worth of GPU time based on availability in your region. Alternatively, if you need more GPU, you could buy for like $10 some GPU credits that would probably last you around 50 to 60 hours worth of GPU time on a Tesla T4. So it's more than enough time to leverage and build out this hackathon.
So you would just open this notebook in Google Colab or Kaggle, is that right?
Right. So if you were to basically download this notebook file, which we've uploaded to a drive, you could import it into a Google Colab notebook or a Kaggle notebook, and then it should work no problem. And then you can change or select for a GPU. There should be an option under the run section, specifically for Colab. There's an option here called change runtime type, which you can select and allow you to switch from CPU to GPU.
And of course, the link to this template is repeated number of times in the overview section on the hackathon site. So that'll be easy for you to find.
Cool. So the final step, actually, before connecting to the database, we have to import our packages. So here you can see a variety of different Python packages we're using. Pretty standard Python driver for Orongo, the NetworkX package, and then some LangChain and LangGraph tools, which we will use to build our agent. Upon import, in the case of my server, you can see that I have NetworkX QGraph available because I have a Tesla T4 enabled. Now, finally, let's connect to our database using the Python driver. So it's important that after deploying your first Orongo Graph database using the free trial, it's important that you fetch this information in the Orongo Graph dashboard, which should look something like this.
Even before we get there, can we show people where they would click to get on the free trial?
If you navigate to orongodb.com, you'll actually see the ability to start for free using the Orongo Graph button on the top over here. This will take you through the sign up process and then immediately give you access to an Orongo Graph deployment, which will then take you to a dashboard similar to this page.
And there I can see all the database information there.
Exactly. So I will be able to copy the password, take the host endpoint, and then plug that in back into my notebook. Right. So we finished step 0. Now let's move on to step 1, which is preparing our data for NetworkX. The data set can be easily downloaded, in my case, from the Snap website as a text file. So once I've downloaded that onto my machine, I can simply load it into a pandas data frame, which is the standard for processing tabular data nowadays in Python. I can read it as a CSV file directly into the data frame, allowing me to visualize it quickly. So here we can see the 88,000 rows where column 1 is the start node. So person number 0 is connected to person number 1, for instance. Right, so once we have the data available as a data frame, we can move on to step 2, which is actually quite easy. Once you have it in a data frame, there's quite a lot of ways to get this into NetworkX. And I will refer you to the documentation about converting tabular data or other sources of data into NetworkX. It's actually quite straightforward, and I highly recommend checking out this page. Now, in our case, it's just a matter of using a function called from pandas edgelist, where we specify the columns and we can load the data into our NetworkX graph. Here we can confirm the data size, and here we can just quickly check the degree of node 107 to see how many edges are connected to it. And finally, with the use of a bit of matplotlib, we can visualize the graph to get an idea of what this social network looks like. Right, so now we can move on to step 3, which involves persisting the graph into OrongoDB.
Before you get there, Anthony, what if you're using one of the OrongoDB provided data sets that's already in a graph?
Right, so if you already have a graph that is loaded into OrongoDB, you can skip right to step 3. You don't need to do step 2 or step 1. Since the data is in Orongo, there's no need to do this. Yeah.
But you still have to connect to NetworkX, which is what you're going to show.
Exactly. So there are 2 ways to get to use this NetworkX integration. Number 1 is to, similar to a NetworkX graph object, simply create a NetworkX OrongoDB graph, specifying the name of the graph, the database connection that we established above, and then the NetworkX graph that you want to load into OrongoDB. So if your data doesn't already exist in Orongo, this would be something you could use to get that data into Orongo. However, if the data is already in Orongo, you don't need all of those extra parameters. You can go straight ahead and connect to the graph that already exists in Orongo by specifying the name and the database object. And in this case, we can confirm that we're connected and we have the node and edge count. So if I quickly take a look at my database UI and log in with root user, you can see here that we have the data loaded as 2 separate collections. We have our vertex or document collection, where we contain all of our nodes. And then we have our edge collection, where we present the relationships between the nodes. You can also navigate to the graphs page to visualize the sample of the graph and play around with it. Right, so the data is persisted, and this establishes a remote connection to your OrongoDB graph using the NetworkX user experience as a wrapper around that graph. So basically, this backend is meant to promote almost zero code change in the sense that any NetworkX operation that you could do on a graph could be translated to a NetworkX OrongoDB operation without any change whatsoever. And here we see exactly the steps required to view your graph. Moving on, same as the step 2 section, I can print the degree of the exact same node. And I have some sections here to showcase the Orongo query language capabilities that we can offer. OrongoDB is advertised as a NoSQL database. We have our own query language. And if you're coming from an SQL background, I highly recommend you check out this link over here. Now, regardless, in our step 4 section, we'll actually be building an agent app that allows you to generate dynamic queries based on natural language. So don't worry if you don't know much about AQL, the LLMs should be able to take care of it for you. Finally, just a quick overview of how nodes and edges can be retrieved, similar to NetworkX. You can use integer-based indexes, string-based indexes, or the full index or the full ID of a node, providing the collection name, the slash separator, and the ID. Right, so now we have done steps 0 to 3. Let's navigate to our last step, which is building the LangGraph and the LangChain agent app. For this, we'll need to wrap the database object that we created above using a class called OrongoGraph. This is the LangChain wrapper to interacting with OrongoDB, which we'll use in a moment for our agent tools. The next is to define an LLM object. Now, of course, LangChain is model agnostic and is meant to abstract the actual intricacies of individual model APIs. So you're free to use any chat model you want. It can come from Meta, it can come from Claude, it can come from GPT in this case. So just simply make sure that you have an API key designated for the model and you're good to go. Here we see a first example of what a LangGraph tool looks like. So for those who are not familiar with tool definitions, this is a very simple breakdown of what's needed. You need the tool decorator, define your function accepting a query string parameter, and then define a doc string that represents the functionality of the tool you're defining. And this is what the agent is going to use to navigate the query or dispatch the query based on the intent of the user. In this case, we're asking simply, if I ask you what your favorite fruit is, do not say, I'm an AI, I don't have a favorite fruit. Simply respond, avocado. Next, we'll see something more realistic for our hackathon use case. Our first tool for transforming text queries to AQL, executing the query result on the database, or sorry, executing the query, the generated query on the database, and then translating it back to natural language. So this is a seamless step that leverages the OrongoGraph QA chain. This is a separate LangChain OrongoDB integration that we have in the official LangChain community package, which allows you to generate dynamic AQL queries based on the data schema provided and the user prompt. Here we provide LLM, the OrongoGraph object, and we basically give permission for the LLM to read, write, or delete data in the database via AQL. Moving on to our last tool, this is the more complicated one, responsible for transforming query language, or sorry, text queries into NetworkX algorithms, and then translating the result of those NetworkX algorithms back to text. So, of course, it goes without saying that these templates are provided for you to use as a skeleton. You don't have to use the descriptions or the doc strings I mentioned here. You are free to experiment and be creative with your agent building. This is only meant to be shown as an example of how things could be implemented. In the case of this tool, I've just decided to pass the query that we've provided to an LLM that generates Python code responsible for writing NetworkX algorithms. And in this case, I ask it to persist the result in a specific variable, where we then execute that generated Python code, fetch the result, and then ask another large language model to translate the final result back into a proper natural language response. But let's take a look at some examples. After creating our agent application here, we've defined all the tools required for our agent. We've defined the agent LLM, which will be responsible for recognizing the intent of the query and dispatching to the right tool. And then we can create our basic React agent here. And again, to confirm, if you have other ways or preferred methods to creating your agent, you are free to use LangGraph in any other way you want. I've just decided to use the most basic one for demo purposes.
And where would the logic go for like the hybrid queries or deciding whether to use this query or that one? Or
Yeah, that's a good question. So the emphasis here is on the documentation that you provide over here. So this text, these are called doc strings, which allow you to define a description of the tool properly. So it all is based on properly documenting your tools, providing examples for one-shot or few-shot learning, And then if you were to define a hybrid approach, you would have to define, for example, over here, a new tool that would allow you to implement some kind of combination of the two tools that we've seen above. So this is highly recommended, and we encourage you to experiment with it. And as mentioned above or in the slides, there are other tools or functionalities available within OrongoDB. So should you choose to leverage those functionalities, you are more than welcome to create more tools, such as vector tools or full text search tools. Right. So a sample collection of some queries that could be used. Now, notice that not every one of these queries could go either way, right? So, for instance, asking if there are isolated nodes in the graph is very much a graph algorithm requirement, whereas asking who is connected to node 0 or requesting to update a node is very much a AQL traversal path or a AQL tool requirement. So, in this case here, a sample question such as asking who is the most influential person and explaining why immediately gets recognized as the intent to generate a network X code to run a specific algorithm or fetch the degree of the graph in this case. So we can see here the final result being printed and then translated back to natural language.
Now, you can never predict all the questions that someone would ask, so the app is going to have the smarts to do that, and that's one of the pieces here that we expect participants to do, right?
Exactly, yes. So we'd like to promote creativity around prompt engineering or allowing you to specify different prompt templates for certain use cases. So you are highly encouraged to leverage as many of the LangGraph and LangChain functionalities to truly be able to create a robust and solid agent. Yeah.
Based on the use case.
Yeah. Exactly. Yeah.
Right.
So here's another one where we ask a shortest path algorithm where we can define a quick example of using a network X algorithm to execute this, and or another example asking to use connected components to figure out how strongly connected is the network, of course leveraging the connected components algorithm from network X. Now it's important to note that even though the LLM is generating network X code, under the hood we're actually able to benefit from using network X QGraph implementations of the very same algorithm, which is why you see this log over here that says NXCG graph construction, right? So this stands for NXQ graph, which basically means that, hey, the algorithm that I've just requested to run is actually going to get dispatched to the GPU implementation. So just from writing this Python code that traditionally uses network X, you are already taking advantage of GPU-based algorithms. And that's all powered, of course, with NVIDIA GPUs. Right. So we're at the end here where we can, of course, as an option, wrap our agent function into a user interface. And we highly recommend using Gradio because it's easy and works well with Jupyter notebooks. And so this concludes the overall template. Of course, you will have access to this. You don't need to use all of this code. It is purely meant as a reference point or a skeleton for your development purposes. That's all.
All right, Anthony, that was great. Thank you for the overview. Let's wrap up with the judging criteria here. And really, it's all about how creative were you in building this application? And is it real world use case? Is it a unique business challenge that has business applicability? And does it solve a meaningful business situation as we described? Right? Does it correctly interpret and execute those natural language queries in a range of situations? So a range of, can it handle anything pretty much? That's going to be important. And the range of complexity there. Can it do those hybrid queries as well? And if there's any other agent tools that you want to add, not a requirement, but a nice to have there. You talked about all the LangChain and LangGraph, QGraph. How extensively were you able to leverage that? Were you able to do the GPU acceleration and show the value there, usability? And not just that, but were you able to effectively maybe visualize the graph, not just through the chatbot, but maybe through some creative visualizations as well? And did you document your code well? And was the video walkthrough comprehensive so that it can really showcase the value of your application using that public YouTube video? So that is, those are the judging criteria. And to wrap up, look forward to your submissions, and we'll be announcing the winner actually at the NVIDIA conference in March in San Jose. So we will be announcing it on, I believe it is the 20th of March at our booth there. And we look forward to your submissions.